So, taking a look at, this is just for our math lab class, so something we did in class here, which some of you, if you weren't here or didn't finish it, will need this to help. Now, these first four are just examples. So, all we're doing is the arithmetic sequences, which arithmetics, they grow by repeated addition or subtraction, okay? We're also just doing recursive equations, okay? Now, recursive equations connect the outputs, right? And it's kind of how we think about a pattern. So they're weird in how they look, but we need two pieces of information. We need the start number, and we need the growth, okay? If we have those two pieces of information, we're going to be able to write our equation. So let's do that first, okay? So as we look here, negative 21 to negative 1, to positive 19 to positive 39, we should be able to see that our growth is we're adding 20 each time, okay? Now, there's kind of a debate about where the start would be. Most of you, if I said, where does this start, you'd say at negative 21, okay? But when we're dealing with sequences, that's really just the first term, okay? And this would be the second term, the third term, fourth term, and so on, okay? Now, the first term really isn't the start. When we talk about what the start is, the start, mathematically, we think of that as the zero term, okay? The term before the first, where it begins. So we'd have to go back here, going backwards using our pattern to find that start number. Now, we do that, and it helps us later on when we deal with explicit equations, when we deal with some other things. So it's just a good habit to get into. So this would end up being negative 41, because negative 41 plus 20 is negative 21, okay? So there's our start and our growth. Now comes the weird part, okay? So what we need to write is we need to write a sub 0 equals our start number, negative 41, okay? Then a sub n equals a sub n minus 1 plus 20, okay? Now there's a few things about this that we need to talk about, okay? That 0 right here represents that it's the zero term, okay? Which is why we put negative 41 there. The a sub n represents the next term, the a sub n minus 1, the previous term, and we add 20. Now, the n, the 0, and the n minus 1, these are subscripts, okay? So if you were to write it like this, it's incorrect because that's not how you write it. Plus, you'll get really confused about what's happening here, and I see people, instead of putting the minus 1, they put the pattern there, and that is not the correct way to do it, okay? So the thing is that this piece and this piece are always going to be the same. So honestly, I could go ahead and go like this and write them all down on every single problem to begin with. And then all I would be worrying about is putting the start and the growth in there, okay, which is definitely something I can do. Now, if you struggle with this notation, another way you could do it is just to like write it out in words what it means, okay, where a sub 0 would be that start number, a sub n would be the next number, and then a sub n minus 1 would be the previous number, because this is really what you're saying, okay? So if you needed to, you could use it like that and say, okay, this is growing by subtracting by 4, so to get my next number, I take the previous number and I subtract 4 from it. Now where did I start? Well, I go the opposite way. I'd start at 6, because 6 minus 4 is 2, and say, where did I start? Well, we started at 6, okay? This means the same thing as over here on the left, okay, of this part. Same way, so a sub 0 is representing that start. A sub n, the next number, a sub n minus 1, the previous number, okay? That's all you're really saying, okay? And it has to do with those term numbers. So like, let's take number 2 and let me write it in a different format, okay? So let's say I was going like this. So the n would be my term numbers, okay? So my sequence the first term is 8, then 11, then 14, then 17, and then I don't know. Okay? So that a sub 0, that 0 here, is representing this 0 here. Well, what number is the a part, right? This a sub 0 tells me that it's the output number that I want. Well, it looks like we're adding 3 each time. So going backwards, that would be 5. So when n is 0, a sub 0 is 5. Okay? Now, the interesting thing is here, and this is something that I don't generally do with students, but that a sub 0, because 0 is right here, if I wanted the first term, I could definitely put a sub 1 equals 8. Or the second term, a sub 2 equals 11. Or a sub 3 equals 14. I don't have to put the a sub 0 there. I could put a sub 1 or a sub 2 or a sub 3. The reason I put 0 in there is to get used to doing that when I'm dealing with these problems, because later on it becomes a lot more useful. Okay? Now, also kind of thinking this same line of thinking, that a sub n, so n represents any one of these numbers. It's like, which number are we dealing with? Let's say I wanted a sub 5. Okay? That would be the next term. So then I'd go a sub n minus 1, which would be 5 minus 1. So 5 minus 1 is 4. So it's saying, oh, what's this previous term? Well, it's 17. Okay? A sub 4 is 17. Well, how am I going to get to a sub 5? Well, we take 17 and we add 3 to it. And we get 20. So a sub 5 equals 20. Okay? That's kind of what that n and n minus 1 mean. For us, all that means is we put a plus 3 right there. Okay? So that's kind of some different ways to try to think about the problem, if that helps. Okay, looking at number 3. Sometimes it's hard to tell in the first two numbers what's happening, but as we keep looking, we should be able to easily see we're subtracting 100 here. So my growth, minus 100. Going backwards, what minus 100 is 23? Be 123. So I start at 123. Okay? So that's really all there is to it. Okay? Hopefully. So it is kind of complex, but again, let's talk it through one more time. Okay? So let's look at number 6. So what if I want to find this next term here? Okay? What am I going to do? Well, that next term is represented by the a sub n. Okay? Well, in order to find it, I need to figure out what the pattern is, right? Okay? So, actually, let's go like this first. Okay? Plus, I need to know what the previous number is. That a sub n minus 1 represents knowing that previous number. Okay? Then, as we look at the pattern, we can see we're adding 10 each time. So, if I want to find the next number right here, I'm going to take that previous number right here, and then I'm going to add 10 to it. So to that previous number, we add 10, which gives us the next number. Again, that previous number here, represented by the 1 up here, plus 10, the pattern, that together is going to give us the number that we don't know. So that's what that bottom part is telling us. But then we've got to go back and say, okay, I don't know where I start. I need that 0 term. So I have to go back here to 41 to figure out where I started. Okay? And that's pretty much all we got going on here. So, again, if you really wanted to, you could start off and you could just put this information down for every single one of these problems. And you're okay doing that. Again, make sure that n minus 1 and 0 is lower than the rest. As you can see how I write it, get in the habit of writing it like that. But yeah, there's no reason you couldn't just go ahead and do this, because that part is always the same. Then we just go through and we find the growth and the start number. So growth here, I am adding 6 each time. So growth goes right there. Okay, the growth here, I am adding 9 each time. So put my growth down. The growth here, I'm adding 200 each time. Okay, do you see how that's the same? Then for the start number, we just go back 1, and that would be negative 22 to start. Okay, we go back 1, it would be negative 177 to start, because negative 177 plus 200 is 23. Going back, it would be negative 26, and we'd add 9 to get negative 17. Okay, so that's really all that's happening here. Okay, so it's really hopefully not as complex as it would seem. So here, looks like we're adding by 5. Going backwards, that would mean that's 7. Here, we are adding by 2. So going back, we go down to 7. So a sub 0 equals 7. A sub n equals a sub n minus 1 plus 2. Okay, number 11, 13 to 7 to 1 to negative 5. We're subtracting 6. Going backwards, we would end up with 19, because 19 minus 6 is 13. Number 12, 8, 11, 14, 17. We've actually seen this guy before, haven't we? It's the same one somewhere up here, isn't it? Yeah, number 2. So again, for that one, a sub 0 would be, going back, it's 5, right? Because we're adding 3 each time. Okay, and that's really all there is to it. So again, you got to remember that we always do those same pieces. Okay, 1 to negative 6 to negative 13 to negative 20, we're subtracting 7 each time. So going back, it would start at 8. So a sub 0 equals 8. A sub n equals a sub n minus 1 minus 7. And the last one, we are subtracting 2 each time. So that would, going back, would be 38. So 38 is a sub 0. A sub n equals a sub n minus 1 minus 2. Now again, if you really wanted to, I could actually say a sub 1 equals 36, and a sub n equals a sub n minus 1 minus 2. Those are the same things, okay? But getting in the habit with the a sub 0 is a better habit to have, so that's what I suggest doing. All right? Okay, guys, there we are.